In Galgotias University, we have next gen structural analysis lab and also next gen smart hydraulics wing. Now here we are doing experiments related to structures and basically structural analysis which are related to beams, frames, arches and curved bars as well as the struts and the columns. So today we will see how the experimental work is performed by the students and myself, Dr. RameshBabu, explaining the moment distribution method to the students. So this is a portal frame where the load is applied at a point A at a distance of 0.2 meter from the left end and 0.3 meter from the right end, that is C. Now this analysis is divided into basically two types. The first one is the non-sway analysis and the second one is sway analysis. Using the reactions R and R star, we will be finding out the factor, that is coefficient K. And after finding out the coefficient K, the final arbitrary moments are multiplied with the K and they are added to the non-sway analysis moments. Then finally you get the values of the unknown reactions at these support A as well as support B. And also we will estimate what is the deflection. So here we go. Now the next gen structural analysis lab, the calculations and the principles of moment distribution method are explained to the students. The students first listen to the lecture and later on they do the manual calculations, and before performing the experiment they complete the manual calculations. While performing the experiment they verify whether the manual calculations match with the experimental values, and they do error analysis as how much percentage of error or how much the manual calculations differ from the experimental values. So all these are being performed by the students. Now, these are the basic calculations which was explained to the students, and this is non-sway analysis. And here we are finding out the reactions. This is the force needed to prevent the sway. And here you can see sway analysis, and this R star is the sway force required for causing a deflection delta. This is sway analysis. And as I told you, the R star is estimated, which is the force which is required to prevent the sway. And after that, the coefficient K is calculated. Then here, these are the final arbitrary moments which are then multiplied with K. And these are the non-sway moments which were performed in the non-sway analysis. Then we add these two, that is, we add the K star M plus non-sway moments M, and these are the values of final moments. And here is how the calculations were explained to the students. And here you can see the students performing the calculations with the calculator. Basically, they are first finding out the moment of inertia by using vernier calipers. They find out the dimension of the cross section of the frame, and using the dimension of the cross section they estimate the moment of inertia. Then they substitute it in the values and they calculate manually. This manual value also matches with the value that is being obtained in the experiment. And finally the deflection was found to be 0.57 millimeters and the reaction was found to be 1.412 Newton. And here you can see the calculations for a load of about 500 grams. That is approximately 4.905 newtons. And here you can see that the deflection is 0.6 millimeter, which matches with the 0.57 millimeter. And also here you can see moment is 0.123 Newton meter and the reaction is 1.51 newtons. So these are accurately estimated by the students. The Young's modulus of elasticity for aluminum frame is 69 GPa. Yeah, thanks a lot for watching. If you have any queries, please mention in the comments.